Good afternoon. Welcome to the afternoon session here in Ballroom 2. Our first speaker is Mr. Mattie Casper, whose talk is entitled Embedding Embedding Python in the Counter-Strike source.
All right, let's test this mic again. Does it sound okay? All right. So I'm Mattie Casper. I'm a principal design engineer at Citrix Systems. I'm not actually here to talk about Citrix stuff. I'm talking about stuff I do on the side. A note here below. I don't work for Valve, who makes Counter-Strike or whatever, but I have worked with them. But I'm a big fan of their work. So what we're going to talk about today is an initiative of using Valve's Source SDK to create a C++ plugin that plugs into Counter-Strike Source to allow Python scripting. I'll talk more about it. Today we'll go a little bit of, I'm going to give you a quick demo. If you were here early, you probably saw some silly gaming going on. I'll show you a little bit about what that was. Go over some of the goals of the scripting language we chose, why we chose it, and what we were hoping to get out of embedding a scripting language into Counter-Strike Source. And in the end, what we got out of it, what the problems were, what the issues were. We'll go over some of the future possibilities we have for EventScripts now that we have Python support embedded. So let's hop right into it. So just a show of hands, who here has heard of the games Half-Life, Counter-Strike, Counter-Strike Source, Half-Life 2, Team Fortress 2, Portal? Okay, a lot of people here. Maybe that's why you're here. So then I'll gloss over the background. Basically, I'm going to give you an idea about the source engine. When I say the word source, it's not in the typical source code. Actually, that's where the name derives, but that's the name of an engine from Valve, a game engine from Valve. The first thing I mentioned is the game Half-Life, very popular back in 1998, Game of the Year 1998 from Valve Software. It's a first-person shooter, single player mostly, where you kind of go and you fight aliens and the like. That was released by Valve in 1998. It has a very active modding community. By modding, I mean enhancing the games, creating your own games around the engine that they provide. The Half-Life original engine is they call it Gold Source. And that's one of the mods. On top of that was a popular game, Counter-Strike. It was hugely popular when it came out, over the 2 or 3 years after it came out. And it was first released in 1999, but it's still incredibly popular. At this very moment, probably, unless they're all here in this room, there's 70,000 people, 60, 70,000 players playing the old Counter-Strike released in 1999. A lot of sticking power, still very popular. Valve, building on the great success from Half-Life games, they created what they called the Source engine, which was named for the side source tree in their source control. And that fueled Half-Life 2, Counter-Strike Source, which is in the title of the presentation. It was also licensed by Troika to produce the game Vampire the Masquerade Bloodlines, which, interestingly enough, also had a little Python embedding in there for some of their story scripts. And then basically Valve produced, most recently, Portal and Team Fortress 2 on an adaptation of the Source engine. It's I didn't go too much into it, but these engines are really kind of physics engines and graphics engines that software that can be used to create new games, that sort of thing. And the Source engine is very extensible. So a little background about EventScripts. Basically, it takes the SDK, the C++ SDK that Valve provided for plugging into the Source engine, and builds upon it to create a scripting engine that anybody can write additional scripts to enhance the game, so they don't have to be C++ coders. So initially, EventScripts, when it was first introduced shortly after Source came out, it was a lot like a shell-like language. It was when I say shell, I mean things like bash or batch files. It's in a way, it was just enhancing the game's console. So the game has a top-level console that's used for developers or administrators to do small tasks or to ban players or whatever. But it didn't really have much in the way of scripting. This example here basically is one of the earliest sort of EventScripts scripts you could write. EventScripts, hence the name, whenever an event would occur, like player death, when a player dies in the game, it would execute this config file, which was just basically a sequence of commands. And in this case, what we did is we had a console command called if that literally just parsed this string here and did the logic tests to see if, in this case, if the weapon they used was a knife, then it executed this other console command called ESMessage, and in this case, maybe it tells, since knives are really hard to get kills with, it humiliates them by mentioning that. That was the original language. The philosophy there was to allow people who didn't have C++ backgrounds to hop in there and customize their game servers for the source engine. So the focus really was a very friendly community and easy to use language that people who've never done any scripting before and actually are afraid of scripting would dive in and try to tweak and use. Well, EventScripts 2.0, we decided to look into other scripting language possibilities, and we added Python support. And that's what this presentation is about. We'll show why. But the combined versions of EventScripts and the 2.0 and 1.0, currently about a third of all source gaming servers that are running right now, that's about 12,000 of them, include this scripting engine because of the power it has to enhance the server, and because the community is so thriving, and there's over 1,200 add-ons of people, average, everyday teenagers, kids, people who've never scripted before, who are writing tweaks for this that get installed on these servers. Just to give you a brief overview of what, for people who aren't familiar with it, just to give you an idea of what the diagram would look like in a networking sense. So you have all these remote players out on the internet. In this specific case, they're remote players on the internet. And some of the challenges we had is because of this side here, where typically these games, they support 32, 64, 16 players. They're not like the massively multiplayer games. But what you do is you have rented server instances where you'll go to a company and basically say, hey, I want a gaming slot for this many players on your servers. And they'll stack as many of these as they can on a dedicated server. And basically you have a rented server instance that runs a single process for the server. It loads the EventScripts DLL inside of it, and EventScripts can execute these Python scripts simultaneously or independently. So I'll briefly show you a quick little demo. First I'll show you the script that I wrote. Just to show, it's a very simple two-line script. Can you see that in the back? This is what was demoing when you came in the room initially. The first line here is import ES, and ES is the name of the module that EventScripts is exposing back to Python scripts. That provides a lot of access to the source engine, to a lot of the SDK. In a way, it's a wrapper around a lot of the source SDK functions that Valve provides. And then we have import player lib, which is kind of a higher level thing that lets people do things with players in a simple form. And so you'll see the script here. We basically define this method player hurt. And we're going to get the player based off of the event information of the user ID who was hurt. And then in this case, we're going to take this guy, we're going to push him vertically in the air 1,000 units. So when you came in, you may have seen this, what I'm about to show you, and might have been wondering why that was happening. And this is why. It's just a short two-line script. So normally, if I come over here to this guy, just to mention, if you do this on a public server when you're playing, you'll probably get banned. You're not supposed to shoot your teammates, but I'm doing it for the sake of this demo. So normally when I shoot one of my teammates, he yells at me and gets hurt. Or when I normally shoot a player, they normally get hurt. But what I'm going to do here is ES_load popcorn. And now the game environment's changed. And now if he gets hurt, he flies in the air at roughly speed. So it changes the game a lot. I mean, this isn't a published script really, it's just made for this demo. But this simple script changes the game to a game of juggling people in the air with bullets as opposed to trying to kill them on the ground. It gives a nice variation on the game. All right, so I showed you a little bit of background about what EventScripts is and what we're doing in the source engine. Let's talk a little bit about why we wanted to go this route and what we got out of it. Key to our community, as I stated at the beginning, was the ability to was the ability to have a scripting thing that was easy to learn. It didn't intimidate people. It didn't scare people away. There was a lot of scripting solutions. There's a few different scripting solutions for Source that kind of took a C approach, C++ approach, and we wanted to go with getting admins and new people to hop into here. So whatever language we chose had to continue with that model to either be a stepping stone or to move on with simplicity. As probably a lot of you have heard, and we've talked with some other educational talks here at PyCon so far, Python's already a good beginner language, and that's really why I began looking at it, because it's already solid beginner language, simple syntax, almost like pseudocode often, especially if you can do well with it, if you can hide some of the complexity, which Python is also helpful with too. The dynamic nature of Python in general allows us to kind of, when we're trying to help people just get initial coding started, there's a lot of complexity that we can hide just from the idea that we can kind of tweak the way Python behaves. Here's an example. It may be hard to see in the back because it's not on the screen. There we go. This is an example file from our early prototypes when we were first writing this. This kind of goes from a senior engineer or just a traditional engineering background. The object-oriented nature, like having classes for an add-on to the server, and also registering directly for events, kind of like the observer method, observer design pattern. Those are pretty common, and a normal everyday developer isn't going to cringe at those, isn't going to care. And this is what really originally what it looked like for the first prototypes. But it was quickly clear that that was going to be way too complex and kind of turn people away. So came up with a dynamic nature. This is the exact same script, but literally it's just saying, we're going to treat it as a module. It's going to be a module-based system instead of class-based necessarily. And we're automatically going to, when we load the module, look for methods that are named after the events they want to register for, and automatically hook that up for the new guys. They can still do the complex setups like this, but we hide that until they're ready to start learning that or start playing with it or get more power. So another big concern for choosing a scripting language for this was that Source runs on both, the Source server runs on both Windows, where you typically have your client for the visual, and it also needs to work on Linux, on a variety of Linux flavors. In addition, as I mentioned before, we have to support rented game servers. Now, these rented game servers are usually very locked down. The admins don't have shell access. They can't install anything. They're basically given, they can have an FTP perhaps, maybe a web console that allows them to start, stop, and upload files. But in this context, they don't have what you normally consider as renting a server or renting a full server. You don't have as much control. So in that environment, it's important to handle our distribution a certain way so that we can have one distribution file for Windows and Linux. I mean, interestingly enough, a lot of the gamers don't even know if their server is Windows or Linux. They just say, give me a game server from a rental company, and they say, okay, here's a Counter-Strike server, you're all set. And they don't even know what the OS is running. So we run into issues where basically we want to package this EventScripts plugin in a way that'll work on both these platforms. And so we have a lot of issues around that. For example, because EventScripts is a DLL or a shared object loaded into the process, already existing process of the source server, it doesn't have as much control over its environment as you would if you were embedding Python into a normal everyday app. Say you had a notepad and you wanted to embed Python in it. Notepad itself controls the process space. And in this case, because of that, when we link against Python, the Python DLLs, we can't guarantee we're going to be able to find them when the server starts and we load EventScripts. So what we had to do is a lot of tricks to try to get it where when EventScripts is loaded, it's able to find the Python DLLs or shared objects that it's using for embedding. In this case on Windows, I won't go into too much detail, but we use a trick for delay loading where you mark a DLL for delay loading, and then we sneak in there, do a load library on it, and then when it tries to be invoked, it's already in memory and Windows doesn't have to search for it. In addition, on Linux, we compile with the rpath option, which allows us to specify, it's kind of a trick, it allows us to specify to the Linux library loader where to find the Python DLLs. Both of these had their issues, but most of them work out. There's a couple more issues, but for the sake of time, I won't go into too much detail. One issue is that it was really important to be able to cross-compile easily this solution for Windows and Linux. And unfortunately, Python on Linux wouldn't allow an embedded app to very easily kind of say, ignore the whole OS directory structure and just focus on our subdirectory for your path issues. And it would always append a /lib to the end of wherever your Python home was, or whatever those directories were. And that wasn't where they were stored because Windows needed it in a different format. So literally had to change the CPython source code to make that happen. In addition, we had compilation issues where on Linux occasionally, we didn't have all of the prerequisites for every single important module that Python has. Like for instance, SQLite 3. I don't know if it's considered important, but certainly important to us. And as a result, those would quietly fail in the configure and the compile, and we wouldn't find out until later testing that those weren't included in the package. And another big issue we had is directory names with colons, which was important for source server. Basically, a rented server instance would usually give you an IP :port in your directory name. And so this isn't a common scenario people are going to run into on Linux where they're going to have colons in the directory names, but for some reason these large companies do this. And it breaks Python's paths because colon is the Linux path separator. And there's other modules like the codex module, which just break completely when it's building its codex search path. Anyway, there are bugs in the Python bug tracking for this. One of the big considerations for this, and it was actually interesting to hear it mentioned in Why Python Sucks keynote this morning, was the topic of performance for Python. It's very important to maintain game responsiveness for these users. I mean, it's a very CPU-intensive game, and we want to be sure that they don't feel lag or a reduction of hit registration for their firing. Well, we already knew that we had acceptable performance from our shell language, which was just string interpreted. So it was certain that Python was going to be a gain in this area. And even with the interpreted language, we saw that that was contrary to everyone's expectations, that it could become popular enough to be on like 25–30% of all game servers because it really didn't impact things enough. And we saw with the Python bytecode, a significant order of magnitude improvement over that. Users were very happy with that. And we also included the Psycho module, which may not, it's been talked about in previous PyCons, for doing kind of on-the-fly native compilation of Python bytecode into native code. And we used that in certain cases where there was a lot of bottlenecks. Another important thing I'm just going to touch on because I'm getting low on time is security. One kind of scary thing about game servers is that hackers really don't have any repercussion for trying to break into a game server of one of their friends or some other friend. It's not like a typical business server. They do it for fun, and we really can't add anything in here that will give them access, if they compromise the server, that would give them easy access to the power of Python, because Python scripts can really just do whatever they want. And there's no excellent sandboxing mechanism yet for Python. So we had to restrict Python access from the game console, which was a little annoying, but we couldn't have any hackers getting access to Python from the console. And then all the scripters in the community are warned against using eval and exec to avoid Python injection. Multiplicity, an important concept here is that we need to be able to load multiple add-ons independently of one another. It's not just one script running at a time. It's multiple add-ons not impacting one another being loaded into the server. So right now we load them as modules from a package, kind of a contrived package format. If I had to go back, we'd probably use an import hook. But now we basically simulate packages by creating little init py files in there. But as a whole, we load them as modules, so it gets rid of the namespace collisions, and then we have them automatically register those event listeners. And that event manager also isolates exceptions so that it just prints out an exception when it happens and then continues on without breaking all the rest of the scripts. One problem we have with this, and I asked about it a little at the keynote this morning, was about threading. Multiple add-ons that are trying to do multi-threaded, basically background tasks, asynchronous tasks like query a web server, that sort of thing. They really get starved in this environment, a lot because of the global interpreter lock in Python, which basically requires any scripts using the interpreter to wait on core objects before continuing. So they can't really take advantage of multiprocessors and multi-cores on OSs. And that turns out to be a problem for us, especially because embedded apps like ours don't have a real recourse for that, and I'll talk about that in just a moment. Future for EventScripts. Briefly, one of the things we have that we have in private beta is a thing called ES-install, which allows us to simulate like the easy install from the dist-utils mechanism that Python has. We have an add-on database, and people can ES-install to quickly install those add-ins from that repository. We also have in EventScripts, what we're hoping to do is take the EventScripts shell language, since it's a very simple language, and actually compile that to bytecode, Python bytecode, and get all the performance benefits we would get from normal Python code. As I mentioned, the pain points here, threading, GIL hurts. It hurts for us. Embedded applications like this, where we have a source server that requires 300, 400 megs of memory, we can't fork our process to take advantage of the normal things you would do to try to avoid contention and take advantage of multiple processors. In addition, when you're embedding an application, your users are using the app for the app and not necessarily for the scripting language. And so while you might be able to convince them to write Python code, you probably can't convince them to go the extra mile and learn C or C++ to release the interpreter lock in between blocking calls for things they want to do. Two other important things are embedding into applications seems to be a priority, not a priority for the Python community in general, and this is kind of strange in a way in a world where embedding technologies into one another just increases in market capitalization billions and billions each year. It's strange to see that it takes a senior engineer to go in and be able to embed it properly into their applications. And one thing that sounds really petty, and it's not something that I noticed because I've been working with Python for many years, and as I've been very comfortable with the current state of API documentation, but I deal with a lot of new scripters that are dealing with this for the first time, and they'll see other languages in other areas, and they'll say, I just can't get a grasp on Python. I know about getting inside the interpreter and doing dir and help to get a better perspective, but it's just not working. I need access to documentation that has a full page for every method, allows user comments on, give snippets, that sort of thing. And if, to really increase and really help these new scripters, we need it as a community, and we're introducing a lot of new people in the community now, as a community to work to come up with a better solution for really good web-based documentation for Python API. A lot of us have gotten really used to it, so it's not that big a deal, but new scripters coming into it get really lost very quickly. So wrapping up now, there's another, I just want to mention briefly, there's another project for SourceMod, basically trying to get Python also on the source engine, so we're going to have multiple opportunities there for other things. And then when you download the slides, I have some links there. As I mentioned, the community is huge. We have a lot of gamers. There's a lot of silly gamer names up here, but there's a lot of people who've really spent a lot of time and learned from scratch how to do things in Python and created all sorts of things for the community. And I just wanted to thank them here. So. Any questions? Go ahead.
How far down the road, or how easy is it to do this with like Team Fortress 2?
That's a perfect question. The question was, how long will it take to get this in Team Fortress 2? And which is a new game just released on the Source Orange Box edition with the new game portal. TF2 is the TF2 version of this is in private beta right now. And so we're writing on a script. I'm really excited about it. I wrote a cute little script that takes the sentry sounds from Portal. If you've heard of it, the sentries all make cute little noises, and tries and applies them to the sentries in TF2. And there's a couple of servers out there testing that right now and playing with it. So it's fine. It's coming very soon. The only problem is Valve hasn't released the Linux aspect of the SDK for Source for Orange Box, and so we have to wait until that's out before I want to really release it to the wild. But I do have a Windows version that works great. So. Good. Oh, day of defeat source. Okay, so. Mm-hmm. Uh-huh. Yep.
And there are certain events that work with Counter-Strike source but not Is there ever
So the question was, there's other games built on the source engine, and I neglected to mention this. Another popular one is called Day of Defeat Source. And EventScripts also works on this, and there's a good, healthy scripting community working on this. And the question was, there are some events, like player death and player hurt, that don't fire in Day of Defeat that you can't get access to, but you do in Counter-Strike source. And the problem is that really EventScripts, all it's doing is it's passing on the events Valve provides, and the ones that Day of Defeat isn't firing are literally the ones Valve never fires. So while they could be supported in the future, it's because Valve doesn't provide any information about those type of events. Like player jump, for example, I don't think that's given in Day of Defeat. And right now, Valve doesn't provide access to that. So what we can do is we can also work with them. I have conversations with them every once in a while about problems we have with this SDK, and I can discuss with them the possibility of adding more of those events. But then there's some new events that don't really apply to Counter-Strike and the like. So, but it's really because of Valve. Some more questions? One in the back. Sorry, to bootstrap, what was that? So the question is, if I can hear it, I guess all of you could hear it. But the question was, does EventScripts, is it used to enhance the actual game for game developers? Yeah. Well, I mean, so I'll give you an example. I might not be following perfectly, but to enhance the source game, people create entire mods, huge mods, just using EventScripts. For example, there's one popular, semi-popular one, where they created new models, they created new maps and blaster effects, and they turned Counter-Strike source into Star Wars, with Yoda and stormtroopers and the like running around shooting each other with blasters, in the same thing using nothing but server-side scripts. In addition, there's a very popular mod called Gun Game for Counter-Strike, which is built on this engine, and it runs on like 3,000 servers globally, which is more than like all the servers of Day of Defeat, source, that sort of thing. So people write full game customizations that people still connect with the client, the same client from whatever source game they used initially, but the server is customized heavily, and it affects what the client sees. But game development couldn't really take the client and change it with EventScripts. There's nothing other about client changes. Next question. Sorry.
Hi, how do you make sure that all the scripts run securely?
A very good question. Actually, at the moment, there's really nothing that makes we can try to isolate them from impacting one another, but the scripts currently don't run securely. They could write things to the disk on these rented servers. They could launch processes. They could do other things if the person providing the server or the OS itself doesn't already lock it down or change root the server, that sort of thing. Really, there's not a lot of protection there, except for for security purposes, the ES install auto install thing that I mentioned. We won't allow automatic installation of scripts that have things like exec, eval, fork, a lot of the things we just manually review for issues. Ideally, we'd be able to sandbox this, and I would love to, and I've looked into sandboxing Python for this, and the closest I can find is the RPython from PyPy, but that's, but I haven't been able to find anything.
Have you looked at TinyPy as an alternative where...
I actually was very recently looking at TinyPy to see if it had what we want, but I haven't seen how easy it would be to embed that in both Windows and Linux. But I will look at that. One more question? Go ahead. EventScripts does not use stackless. So it was one thing we reviewed, but at the time we were doing the porting, stackless was lagging behind CPython. It was like at 2.4 while 2.5.1 had just come out. And so I felt that it was more important. I was more interested in staying with something I knew could be supported embedded, and it didn't look like Steckless. I didn't know Steckless was still moving, but as of today, it sounds like they have 252. So it's something we'll consider in the future. But right now, it's pure C Python. Go ahead. Greenlets? Yeah, so basically he's saying that there's another module called Greenlets, which I've heard about as well, which helps you get a lot of the functionality from Stackless, but it's purely a module, and we can include that as well, distributed. Right now it's not distributed with EventScripts, but we could add that. Any other questions?
Thank you, Matty.
All right, thanks guys.